This is the summarize of our lesson in the mathematics in the modern world. So, the first chapter, in chapter 1, we're going to tackle about mathematics. So, what is mathematics? Mathematics is the study of relationship among numbers, quantities, and shapes. It includes arithmetic, geometry, algebra, statistics, and calculus. Numbers are everywhere. In nature, mathematics notice that numbers appear in different patterns in nature, like birds' two wings, three clover leaflets, deer four hooves, five-leaf buttercups, insect six legs, seven rainbow colors, and octopus eight arms. As men of science studied numbers, they also realized the significance in their daily life. Like the discovery of Leonardo Pesano Begoglio, the Fibonacci Sequence, which his nickname was Fibonacci, roughly means son of Fibonacci. Aside from being famous for Fibonacci Sequence, he also spread Hindu-Arabic numerals through Europe in the place of Roman numerals. Fibonacci Day is November 23, as it has digits 1, 1, 2, and 3. So, this is the formula of Fibonacci sequence. Xn minus 1 plus xn minus 2. So, we will make a table. In the first box, we will put the x sub n. x0, x1, x2, x3, x sub 4, x sub 5, x6, x7, x8, x9. Because the problem is finding the Fibonacci x sub 9 of 0, 1, 1. 0, 1, 1. We are just going to add it. 0 plus 1 equals 1. 1 plus 1 equals to 2. 2 plus 1 equals to 3. 3 plus 2 is equals to 5. 3 plus 5 is equals to 8. 8 plus 5 is equals to 13. 8 plus 13 is equals to 21. And 21 plus 13 is equals to 34. So, we are going to check it. So, our x sub n minus 1 is equals to, what is our x sub n minus 1? So, our x sub n is equals to 9. So, x sub n minus 1, x9 minus 1 is equals to 8. X sub 8 plus the value of the x sub 7. X sub 8 plus x, we're going to add the x sub n minus 2. So, what is our x sub n? Our x sub n is 9. So, x sub 9 minus 1 is equals to x sub 8 plus x sub n minus 2 is equals to x sub 7. So, where our x sub 8 is equals to 21. 21. Plus, what is our x sub 7? It was 13. So, to check it, 21 plus 13 is equals to 34. So, our x sub 9 is equals to 34. So, it's correct. In geometry, golden spiral is a logarithmic spiral whose growth factor is the golden ratio. The golden spiral gets wider by a factor of, in geometry, logarithmic spiral whose factor is the golden ratio. As you can see in the figure 4, the golden spiral gets wider. By the small box, it has a value of 1 only. Plus 2, it becomes 3. And 3 plus 2 equals to 5. And 5 plus 3 is equals to 8. And so on and so forth. Just like in the other figures in Fibonacci spiral. Chapter 2, Mathematical Language and Symbols. So what is language? Language is the system of words, signs, and symbols which people use to express ideas, thoughts, and feelings. Every science has its own lingo and word usage. Next is mathematical language. It's the system used to communicate mathematical ideas. So there are four main actions attributed to problem solving and reasoning, according to Kene, Hans, Swiss, Ewer, Metzisto, and Tato of 2005. Modeling and formulating, transforming, manipulating, inferring, communicating. That is the four steps in problem solving and reasoning. I've also learned that mathematical language is precise, concise, powerful, clear, objective. Sets is a well-defined collection of distinct objects. Two ways to describe a set: roster or tabular method. In the roster or tabular method, the elements inside the set are listed or enumerated, while in rule or descriptive method, the common characteristics of elements are defined. Kinds of set: empty set, it has no element inside. Finite set, it has countable number of elements. Infinite set, uncountable number of elements. Universal set, it is the totality of all elements. There are two or more sets can be described as equal sets, equivalent sets, joint sets, disjoint sets. There are four operation performance sets. The first one is the union of set. Union of set is a set whose elements are found in both sets. So, for example, in this union of set, I have two sets that has A. First set is A. A. 1, 2, 3. And the second set is B. 3, 4, 5. So, in overall, the symbol for the union of set is A union of B is equals to all the elements found in the set. 1, 2, 3, 4, 5. So the next one is the intersection of set. Intersection of set is that whose elements are common to both sets. For example, A is equal to 1, 2, 3, 4, 5. B is equal to 3, 4, 5. So, the A intersection of B is equals to 3, 4, 5. So, the next is difference of set. It is a set whose elements are found in set A but not in set B. Next is complement of set A. Complement of set A is a set whose elements are found in set A but not in set B. And the last is subset. Is a set which elements of which can be found in the bigger set. So this is the example of the difference of set A and set B. So for example, we have A and B set. So in A we have 1, 2, 2 elements, and B we have 2, 3, 4 elements. So in difference of set, we are finding whose elements are found in set A but not in set B. The element who's not common. So the difference of set of A and B is equals to 1 and 4. Next is the complement of set. The complement of set, for example, we have a universal set of 1, 2, 3, 4, 5. And we have a set A that has 1, 2, 3 elements. So the complement of A is a set whose elements are found in universal set but not in set A. So the elements that are not found in universal set that is in set A is 4 and 5. Chapter 3, Problem Solving and Reasoning. So there are two fundamental types of reasoning. The first is inductive reasoning. It refers to the process of making generalized decisions after observing. Next is deductive reasoning. It is kind of reasoning which is general to specific. So this is an example of the inductive reasoning. Inductive reasoning refers to the process of making generalized decision after observing. So, he observed that John is an excellent swimmer. And he concluded that family has a... And he also observed that John's family has a swimming pool. So, he concluded that John's sister Mary must also be an excellent swimmer. The next one is the deductive reasoning, general to specific reasoning. He observed that all numbers ending in 0 or 5 are divisible by 5. He generalized it. And the second is the number 35 ends with a 5. So he concluded that 35 is divisible by 5. Chapter 4, Data Management. So, sa pag-organize ng mga nakolektang numerical data, may dalawang klase para i-arrange to. Una is yung array. Yung numerical values doon ay naka-ascending or descending. Tapos, frequency distribution table. So, ito yung example ng frequency distribution table. Ito. So, meron po yung sa loob niyan, merong classes, merong class frequency, merong class mark or class midpoint, tapos may cumulative frequency at relative frequency. Makikita nyo naman po kasi nakalagay na sa taas niyan ng box. So, sa pag-unang process is, kailangan, ito na yung mga steps para makabuo ka ng frequency distribution table. Una is yung, i-determine mo yung range. So, yung range para makuha ko, ano yung highest value dun sa mga nakabigay na numerical data, yung highest value, ima-minus mo sa lower value. Yan na. Tapos naman, next is yung K. Yung K, siya ang pagkuha ng K is, ano mo siya, 1, ito na yung pinaka-formula niya, 1 plus 3.322 log n, kung ilan yung mga numerical data mo dito. Kunwari, kung 50 sila, kagaya dito, log 50 yung ilalagay mo. Next naman is pag mag-determine na class size. Yung nakuha mo kanina sa range, i-divide mo dun sa K, at yun na yung magiging class size mo. Next naman is yung pagkuha ng mga mean, median, variance. So, pagkatapos naman kumuha ng frequency distribution table, ang kukunin naman is yung mean, median, standard deviation, cumulative variation, tapos variance at skewness. So, sa mean naman, pag kumukuha ka nun, ipag-add mo lahat ng mga nasa mga numerical data. Kung ano, kagaya dito sa example, pinag-add niya lahat. At kung ilan sila, 1, 2, 3, 4, 5, 6, 7. 7 piraso sila, i-divide mo sa 7 para makuha mo yung mean. Sunod naman is yung median. Kung ilan sila, i-plus 1 mo, di-divide mo sa 2 at yun ang magiging median. Sunod naman is yung variance. Sa variance naman, yung totality nun, ita-times mo sa totality nun, minus mo dun sa mean, raised to 2 over n. Yun ang magiging variance mo. So, sa pag nakuha mo na yung variance mo, sunod naman is yung standard deviation. I-square root mo yun at yun na ang magiging standard deviation. So, sunod naman is yung cumulative variation. Yung nakuha mo kanina sa variance, i-divide mo sa mean. Times 100, yun na yung CV mo. Next naman is yung skewness. Kung paano mo siya i-graph. 0 siya kapag yung mean, median, at mode ay nag-equal. So, nakalimutan ko sabihin, yung mode pala is kung ano yung nag-uli, maraming beses na naulit na mga datas. Kunwari, sa data mo, 3 beses na may ganon. So, yun yung mode mo. So, sunod naman is yung mean. Yung positive. Mangyayari yung positive, dun siya sa unahan nagkakaroon ng slope. Yun ang positive skewness. Yung mean is greater than median, tas yung median is greater than mode. Yun, ang tawag sa skewness na yun ay positive skewness. Kapag negative naman, mababa yung slope niya sa simula, tataas sa bandang dulo, sa hulihan siya tumataas. Mean is less than median, tas yung median naman is less than mode.